Time to summarize. Okay, so the question which we begin the journey, 3 raised to power 91 divided by 4. Okay, what was the remainder? I guess by now all of you must have got the answer for that. Then we covered some binomial properties, coefficients and their properties, properties of expansion. Then the miscellaneous part, which was the most important for IIT-JEE, in which we did integration, differentiation, binomial for any index, and the two coefficients together. And then came the most important part of miscellaneous, multinomial theorem. Okay, and I guess the questions which we discussed in this part have concluded, have summarized the application which we have discussed. Okay, so I hope I was successful in my attempt to make binomial easy for you guys. So for more videos on physics, chemistry, maths, bio, watch askIITians.com. So first question is the coefficient of x raised to power 4 in x by 2 minus 3 by x square raised to power 10 is. So clearly this question you will say it's quite simple. Now this says these are the options, and this came in, actually it came in 1983. Okay, now most of you must be able to do by now. Okay, so but still I will be doing it. So what we will be writing first thing we should write is tr plus 1, the general term. Okay, what will be the general term? 10cr x by 2 raised to power 10 minus r minus 3 by x square raised to power r. Okay, now here what do I need? Coefficient of x4. So what you have to do, x raised to power 10 minus r, and this is x raised to power minus 2r. Okay, this is r here, so this will be forming x 10 minus 3r. Now this power should be equal to 4. Now I need an r such that this power becomes 4. That is my purpose. So if you put it equal to 4, you will get r is 2 basically. Okay, so now you can put back r here. Okay, and you can get the coefficient. So it will be 10c2. You are not requiring x's anymore, you just need the coefficient. So that will be 1 by 2 raised to power r, and this will be minus 3 raised to power 2. Now that will be your answer. You can just simplify it and get the answer. Okay, so this was quite easy, but still this kind of questions definitely appear in JEE mains. So this was specifically put so that you can know that okay, in JEE mains still the level is not that high, but obviously we will have after this some advanced level questions also. Let us look at the next question. It says, if she sends for this, obviously. Okay, now this is a brilliant question. Okay, we have to get the value of this series, and this question appear in 1986. Now what is the crux of this question? Again, if you look here, we did something like now there are, as we can see, there are two things involved. One is the coefficient and one is again the alternative minus sign. So obviously one x series has to be 1 plus x, other has to be 1 minus x. Now let us closely observe first this phenomena and how we can simplify this so that we can get an n is given to be an even. Okay, even is given positive integer. Okay, so this will solve our question a bit. Okay, but let's see it on the fresh page. So this is what we were looking to solve, and here we will be start solving this. Okay, now what we have to first do is here. Okay, now this is c0 square. This I can write as c1 square minus c1 square. This one again plus c2 square plus 2c2 square. Okay, now what I am doing here is, now this one is easy to find. Now whatever is remaining I'll take. So what will be the last term? I'm just taking the 1 out of everything. Okay, cn square. I'll tell you the logic also why I'm doing this. Now this will be minus c1 square, next will be plus 2c2 square, next will be minus 3c1 square square c3, and last one will be plus minus 1 raised to power n, and this n is quite crucial here. Okay, now what we are going to do is, now this one if we can find, okay, so obviously we can see that this is nothing but the derivative of this one. Means if in this equation what would have been the case, this would have been x square x cube, so like this it would have been there. Okay, so now let us first figure out that how we can get this. Okay, now if it was plus, then it was a child's play. We told that it was a coefficient of this thing n minus r, where we just need to put r and we will get this thing. Okay, but here this the crux is that it's alternative plus minus. So let's see which expansion will help us to get this. Again, I'll take this expansion. Now reason for taking this is that what I'll get, NC0. I've discussed this basically in the last part. We did it similar thing, that if we have 1 plus and 1 minus, then how we are going to tackle the things. Okay, so this will be plus NC1 plus NC2. Okay, now this expansion is actually equal to 1 minus x square raised to power n. Okay, sorry, this was n was here. Okay, so this thing is very important to keep in mind, that this term is this one, and we are going to extract the coefficients from here. Okay, NC0 minus NC1 plus NC2, and it will go like that. Okay, now the only advantage here is that the powers are same, so we could have, instead of m plus 1, we wrote it as x square. Okay, so this was easy to simplify. Okay, now let's see what's there in the question. The question says this one, then this one, then the next one. Okay, now instead of this we could also have used this thing 1 by x. Now why we will be using that? But in that the thing which will become easier for us is that this will be the coefficient of x basically naught. Okay, x naught, this thing, and here the simplification would have been x raised to power n in the denominator. Okay, so that was the only thing which would have been extra in this. What I have done is I have just modified this. Why? Because I was looking at that this was C0 C0 C1 then C1. Okay, if it would have been XX, then the coefficient would have been different. This would have been gone for 0, this would have gone for square. So what I did, instead of multiplying equal powers, I took 1 by x here, and this completely modified the things for me. Okay, I'll do it here, that what I've done is I've expanded these two things, 1 plus x and 1 minus x. Now in this one, what I've done is that instead of getting basically NC0, NC1, NC2 here, now here I will be getting into x square. From this I will be getting NC0, NC1 by x, NC2 by x square, like this, and with alternative signs. So that was my question basically. Okay, so this becomes quite easy now that we have simplified the expression. So what do we need? We need the coefficient of x raised to power 0 from that. Okay, and this will obviously be derivative of that, so we can just get the formula for this and derivate. It will be derivative of that only. Okay, yeah, so going for this again, this one again I'll pick this as 1 minus, again things will change a bit here. It will be x minus 1 basically raised to power, so x minus 1, x square minus 1 raised to power n. Now n is a positive even integer. It was given in the question that n is an even positive integer, so we don't need to worry for this thing, even if it's 1 minus x square raised to power, and moreover the expansion doesn't matter. Okay, so this has to be divided by n. So what will be the coefficient of x raised to power 0? Okay, so here the terms will be x raised to power 0, x square, x4, x6. What do we need? We need x raised to power n. So that will be basically nc n by 2. Now why n by 2? X square raised to power n by 2 will give me x raised to power n, and this will be getting cancelled by this. So this was the crux. Now you can see, oh my god, what Amazing. Okay, yeah, so this you can now simplify. Now this reduces, the whole thing reduces to this thing. Okay, again with this sign. Okay, because this sign will be there. Okay, so this sign uh, and again in this case it will basically reduce to, if you look at the, if you expand this, if you look at the, since minus is there, so minus 1 raised to power n by 2 will be there. Okay, so minus 1 raised to power n by 2 here, because when we will be going for this will be having alternative plus minus signs. Okay, alternative minus square, so this will automatically depend, this will, the term will be minus x square, so minus 1 raised to power n minus 2 will be there. Okay, with nc n by 2. Okay, now when you will be differentiating basically this with respect to this part, only thing which you will be getting is this part as the variable term. Okay, and this thing will basically, you can derive similarly this one, like you can try this and you can derive this thing by yourself, that you just need to differentiate basically by equating suitable uh, powers. Okay, now what you could have done here is that you need to here, so at this step, so this I will leave on you guys, that how you can perform. I'll give you a hint for this. Now here what we have done basically, I'll first remove the things bit. Okay, so this thing okay, so now we have got enough space, so we can write. So first thing which we got was 1 by n by 2, nc n by 2. Now next thing, how you will get, now in this expansion what we have done, 1 plus x, 1 minus x, and we, this was the expansion 1 by x basically, raised to power n, raised to power n. This was 1 minus x square, since the n was that thing. Now this thing is left hand side. Okay, now what do we need here is that we will again extract this thing nc0, but instead of that what we will be doing, we will be multiplying it by suitable coefficient. Okay, we will be multiplying by suitable x, and then that you can check that how, when you will be differentiating that, you will be getting a similar expansion like this. Okay, so you can basically do at this level only, that when you are multiplying it here, you can modify the things, try this, and the answer for this I'll give you will be A only. Okay, so this question was a brilliant one. The things will get cancelled from this. Now this is again something, if you can see, this is nothing but reverse of that, nc n by 2. So nc n by 2 will get cancelled with this. Okay, and there will be minus 1 raised to power n by 2 obviously. Okay, and the remaining thing, you will, remaining part you will get from the second question. Okay, so you can try this question, how you will get this thing, and this will be your testing point. Okay, let's move on to the next question. The question says, if in the expansion of 1 plus x raised to power m, 1 minus x raised to power n, the coefficients of x and x square are 3 and minus 6 respectively, then m is. Okay, now again this is a good question, similar kind we have done. Okay, now the best way to do this question will be, now I need x, okay, from multiplication of this. Again this is a very particular question, not particular, but question from which you can learn things. Okay, now you need to pick x. How can you get x? So this expansion will be basically mc0 plus mc1x plus mc2x square plus, it will go like this, 3x cube. From this what you will get, you will get similarly mc0, basically nc0 minus nc1x plus nc2x square here. Okay, it will go like this. Okay, now here to get x, what are the possibilities? Either you multiply this with this, so what coefficient we are getting? mc0, this will obviously minus mc0, nc1. Okay, other way around will be mc1 plus nc0, this one is n. Okay, So these are the two possible cases where you can get x. There is no other possible way. Okay, so this thing you will equate it to 3. Now again MC0 will be 1, this will be n minus n basically, and this will be m only. Okay, MC1 is m. By now you must be figuring that out. So this will be one equation. The other equation similarly you can get from x square. Now how you will get x square? MC0 with square term. So now you need to know that whatever powers you are looking, the sum of coefficient should be that. That is the key thing. And again you can see if both are even, you will have positive. Basically first is positive thing. So if this n1, this one is even or odd, that will decide the plus minus sign. Now if I choose MC1, what will be my choice? NC1. Now this is odd, so this will be negative. Next one will be MC2. We have taken MC0, MC1, MC2. So with this it will be NC0. So these will be the three things, and this you will equate to minus 6. Okay, and again you can get suitably your answer. Okay, and this will again be very easy. The only thing which I needed here was picking up the powers. Now suppose if x raised to power 5 comes out. Okay, so what you will do, okay, we will start with MC0, then obviously NC5 we will take. Okay, why? Because we need the power as 5 if there are only two multiplication. Now this is all minus, then obviously alternatively it will be plus MC1 NC4 plus MC2, or sorry, minus NC3. So whatever power comes, the things which are appearing here should be constant. Okay, that is the power of that's the key concept. And this question, as it's seen that it came in IIT 1999. Okay, moving on to the next question. Okay, this is an analytical question again, good one. This came in IIT 1997. Okay, so you have to prove that this thing equals, so we'll start with right hand side, and we have to prove that this will be equal to left hand side. Okay, now again first we will be simplifying this thing. So this is n factorial over n minus r factorial, and into r factorial. In the denominator you will be having r plus 3 factorial over 3 factorial, r minus 3 minus r, and into r factorial. So r factorial gets cancelled with this. 3 factorial we can take outside. Okay, and obviously minus 1 raised to power r is there. So what I am aiming at is simplifying the thing. Okay, now here is my key to solution. Okay, this thing, this r plus 3 is there, so I can write this as r plus 3. Now what should I make? Obviously n plus 3. Okay, now what our aim in this question is that we are trying to reduce this in the form of NCR. Okay, now I'm not saying n is corresponding to this and r is, so we are trying to bring in this form. Okay, so that I've got this in denominator. Now only thing I need in the numerator is n plus 1, n plus 2, n plus 3, because these things are not gonna affect my summation part. So obviously I can keep 3 factorial here. This will be n into n plus 1, sorry, n plus 2 and n plus 3 here. So obviously these things I don't need, means this is outside. Okay, and like obviously as you can see 3 factorial, so this is part of our answer. Obviously n plus 1, n plus 2, n plus 3. We are not going anywhere and we are not touching these things. Okay, now after this again this will become now n plus 3 cr plus 3 with an alternative sign. Okay, now I can have a look at this expansion of this series. What will it look like when I put it r as 0? It will be n plus 3 c3. When I put it 1, n plus 3 c4 plus n plus 3 c5. It will go like this. Okay, now we did something like, okay, nc0 minus nc1 plus nc2 minus, okay, let me change the color, it's a bit monotonous now. So okay, NC3 plus NC4. Okay, wait, what I am getting here is I'm starting with this one here. Okay, so either I can take common. Now this was equal to 0. If you remember, this was the expansion of 1 plus x raised to power n, and this we put x is equal to minus 1. Okay, so whether we are doing this minus plus minus plus, so this is something like this. The only things I need to here is starting with n plus 3 C0, n plus 3 C1, n plus 3 C2. Now if I take this alternatively, this was plus, so this will be minus plus minus. So this term, as you can see, gets reduced to 0. Oh my god, how simplified is that? Now what since we have added these terms, we have to subtract these terms. So n plus C3, n plus 3 C0 minus n plus 3 C1 plus n plus C2. Now these are the terms we need to simplify. Rest everything becomes 0. What we have done is we have kept this thing here as it is. Okay, we have simplified this into this. Okay, and we have added and subtracted the same things. Okay, so as to keep the expression same, and what we observe that this comes out to be 0. Okay, now you can just simplify this and you will get the answer. So again, brilliant. Okay, so you will just think, and again what I'll suggest that every step wherever you are stucking, okay, if suppose try each question by yourself by pausing the video, maybe in beginning or maybe after solution. Even if you are able to do, pause it, do it. Okay, if you are not able to do, obviously you have the private forum thing, so that will be, I will be conveying it to in the last, that wherever you're getting the difficulties, suppose in the previous question if somebody don't gets the answer, so obviously you can ask that one forum. Okay, but I don't want everything to be phone speed. Okay, so that's why I'm leaving some answers or queries on you. If you're not getting, if you're not, suppose if the answer is not matching or you're facing a difficulty, okay, that can happen obviously. Okay, so for that obviously you can post it on private forum and the discussion board basically. Okay, ask IITian website, so that will be conveyed at the end of the video, so you can listen to that and you can post your doubts related to the video on the discussion board. Okay, at askIITians.com. Okay, moving on to the next question. Okay, the question says, for any positive integers m comma n, let this be the relation. Then we have to prove that the given expression is equal to n plus m or m plus n. Now this came in JEE 2000. Okay, so now looking at this question, the first impression that comes to our mind is, okay, we read a property somewhere like this, n over r plus 1. This goes like n plus 1 r plus 1. Okay, now if you remember this property, you will be easily be able to solve. And again, as I see here, okay, this is a bit mistake here, this will be m by m. Okay, so please make a note of that. And so what this question is, now let us see, interpret in terms of NCM. Okay, NCM, n minus 1 cm, goes like this, m plus 1 cm, and it goes basically, I'll write one more term so that it's more clear. Last term is MCM. Okay, now what the question is about. Okay, now we have this term, so we want to start a chain reaction basically. Okay, now if we want to combine these two, obviously we cannot. Why? Because here we can see that this one and this one, that should be different. Okay, so what should we do now? Okay, now we have noted that we need to increase this one obviously. Okay, so top has to be m. Okay, now what are we looking at? Okay, we have this term. Now if we get this term, we'll have next term as this. Okay, let's see. There will be only two possibilities. Either you can take this as minus 1 if somebody says, okay, why take greater 1, or if I can take this as m plus 1. Now we will observe that what happens when we will combine the two things. In this case, it will become m plus 1 cm. Now this becomes same as this. not of use. Okay, now let's see what this does. Now this will become m plus 1 c m plus 1. Okay, now this has again, now this is interesting, that this will become, okay, m plus 1 m plus 1. Now we have started a chain reaction. The next one will be m plus 2 c m plus 1. Now this was the question which I was talking about when I talked about this property. So now I can combine the next one and it will form m plus 3 c m plus 1, and it will go till we will end up in getting n plus 1 c m plus 1. Okay, so obviously this was the question that needed to be, we just need to start. Now again somebody will say that if I have added this thing, why I am not subtracting this thing? Now if you see it closely, what is this actually? This is actually 0. Is it possible, what does this mean? Is it possible to select m plus 1 things out of m things? No, that's impossible. Okay, that's impossible. We can at most go for, if I say that you have 5 chocolates, can you give 6 chocolates to anybody? No. So basically 5c6, if I'm writing, this is basically 0. Okay, so 0 I'm adding, subtracting, doesn't matter. Okay, what my role is that I started a chain reaction. I need an initiator for that, and I did that. So I started with this and we ended on this, and this is what is given in the proof. Okay, so this one again is 0. Okay, again somebody will say that this does not exist, but I'll say this exists but the value is 0. This is not possible means the value is 0. When we are saying m means 5 chocolates out of 5, it means only one way. If you have 5 choices and you want to choose all 5, you have only one way. But is there any way if you have 5 choices and you have to pick up 6 different chocolates? No, that is a 0 way. Okay, so this was the key step here which we figured out. Okay, so I guess it was clear. The questions which were picked were again, some questions were really very good, especially the question, the second question, which was c0 square. And I'll again emphasize on that please take this question seriously, this one which was there. Okay, and again notice that how you can manipulate at this step when we took this. So basically before taking this we need some manipulation, so that when we pick up the coefficients, okay, accordingly, so you need to manipulate something at this step. Okay, differentiate and get the same coefficients, okay, on both sides. Okay, so that was a trick for that, and I guess you liked it, all the questions which we have discussed. If you have any doubt in this topic, you can post it for free on askIITian website. For this, just visit the askIITian.com, and there you can visit discussion board. It will direct you to Ask Expert, where you can select the category, and according to the category post your question and click the Get Answer button. Experts at Ask IITian will answer your query within 24 to 48 hours. So here comes the concluding phase, the JEE at glance. Okay, here we are going to discuss some of the questions which appeared in previous year JEE, and you will actually get to know the application of binomial theorem which we have discussed, and all the concepts which we will be applying in this part. Let's begin with the questions.